Hello everyone. Today we will be learning pulse amplitude modulation. Let us see what is pulse amplitude modulation. Let us define the pulse amplitude modulation. Pulse amplitude modulation is the amplitude of the carrier pulse is varied in accordance with the message signal is pulse amplitude modulation. Here we are representing message signal G of t, train of impulses S delta of t, and this is the sample signal is represented by G delta of t. Train of pulses represented by P of t, and PAM signal is represented by S of t. This is train of impulses and this is train of pulses. Natural sampling and flat top sampling is a pulse amplitude modulation. Let us see the waveform for this. Here this is the natural sampling and this is the flat top sampling output. Okay. So what is natural sampling? Here this is the carrier. Train of here amplitude of the impulse carrier signal is varied in accordance with the message signal is natural sampling. That is sampled output, this one is. Then flat top sampling, amplitude of the pulses is varied in accordance with the message signal is flat top sampling. This natural sampling and flat top sampling both are pulse amplitude modulation. Here what is natural sampling? The amplitude of the impulses naturally it is varied in accordance with the message is natural sampling. Then why it is called flat top sampling? The top of the pulses are maintained constant. Top of the pulses are maintained constant. That is, it is flat. That's why it is called flat top sampling. I think this is clear. Pulse amplitude modulation is natural sampling and flat top sampling. What is the advantage of pulse amplitude modulation? It is a base for all digital modulation. That is advantage, and disadvantage is it is more sensitive to noise. Where are we using pulse amplitude modulation? That is application is it is used in time division multiplexing. It is also used in pulse code modulation. In data communications it is used, and many more applications with respect to pulse amplitude modulation. Now let us see the demodulation of the pulse amplitude modulation or detection of the pulse amplitude modulation. So how do we do the demodulation of pulse amplitude modulation? We need reconstruction filter and equalizer. So the pulse amplitude modulated signal is given as a input to the reconstruction filter. Reconstruction filter will recover the original message signal, then it is given to the equalizer. Function of the equalizer is it equalizes the pulses. Then finally we are going to get the original message signal. This is the demodulation or detection of the PAM signal. Thank you.